Hello, good morning and a happy new year to all of you. My name is Ashutosh Garg and today we will be talking about fire heaters. The topic we have chosen is improving safety, reliability and efficiency of fire heaters. Fire heaters are one of the most important equipment in refineries and petrochemical plants. In fact, if you see pictures of refineries in newspaper, magazines, you will always see fire heaters in the forefront. You will see fire heaters and tall stacks dominating those things. And fire heaters themselves are almost like a plant in themselves, like a self-contained unit, especially if you have air preheating system. Then we have fans, we have ducting, we have a lot of controls, fuel gasket and lot of burner management system. They have been getting complicated in the last 25-30 years. When we talk of NOx, then we have SCR units, ultra low NOx burners. So fire heaters have been in the news for a lot of reasons. In fact, now we are talking of firing hydrogen in fire heaters to eliminate the greenhouse gas emissions. So that's how they are in news. They had been in news for the past 40 years because of NOx emissions and also because they are major energy consumers. So I chose this topic and we want to talk about safety, efficiency, and reliability, the three most important parameters, operating parameters in fire heaters. Because safety is a big issue. I mean, in my career, I have seen many incidents where during startup, there was an explosion and could have been prevented with good operating practices. Efficiency is a very common issue which is overlooked. Could be due to low fuel gas prices or could be due to stack dampers not working or could be other issues. And reliability is again, poor reliability of fire heaters is costing refiners millions of dollars. They had to shut down their heaters, especially crude heaters, vacuum heaters every 2, 3, 4 years, and it cost them millions of dollars in production losses and cleaning up the fire heater. So we picked up these three issues to talk about this morning. I welcome you all to our webinar and hope then when you go back to your units, you will be able to appreciate your fire heaters and look at them from a different angle. So let us start this webinar, and I'm starting with a brief introduction of myself. I believe most of you know me from my previous webinars. We have been doing webinars since 2019. This is the first one in 2024. I think I'm doing it after 6 months. But 2024 is a very important year for me, actually, personally, professionally. I will be completing 50 years in the industry, which I consider a great honor. I thank God, and I have been very fortunate to be working in this industry for almost 50 years. I passed out in 1974 from IIT Kanpur. I'm a chemical engineer by profession. And since 1976, I've been working on fire heaters. From 1974 to 1990, I worked in India in KTI and Engineers India. And then in 1990, I moved to US, got an opportunity because of NOx reduction in fire heaters. And 1996, I've been working with furnace improvements. I'll tell you a lot about furnace improvements. It's my third child. So that's in a brief nutshell about me. I want to talk about furnace improvements. Most of the industry, the fire heater industry, has been focused on supplying new fire heaters. And back in 1992, when I was working in fire with a KTI, I realized that all fire heater vendors are focused on supplying new burners, new heaters as a replacement, There was no one who was listening to the problems being faced by owners, faced by operators. So in 1996, my career took a change. So I decided to try my hand on fixing existing heaters. I thought, why not I work in this field and work with the owners, operators, and improve their existing fire heaters. So in 1996, I started furnace improvements from my fourth bedroom of my house. We have been very fortunate. We have completed 27 years in the business. We have two offices. We have an office in Sugarland, and our main office is in Noida now. We have a team of 40 engineers who are working very hard and doing excellent projects. This office has been in existence since 2005. One of the things we have done in the past 25 years is not shying away from new technologies. We have been looking at our clients and their needs, have come up with new solutions, and we have 3 patented technologies as of date. And I'm very happy to let you know that we have references for each one of them. We have almost 15 or 20 heaters retrofitted with split flow technology. Similarly, we have about 15 heaters with inclined firing technology. And we have started supplying smart stack dampers. I want to tell you a little bit about how we work. And recently we got a client in India who was experiencing high pressure drop in their heater, and it was limiting their production. So we thought about it, we looked at it. The conventional solutions would have costed him a big amount of money, maybe $1 million or something. And when we evaluated his heater, we realized that we could use our split flow technology and reconfigure his heater without making any major change or any significant change in the heater. So we converted that heater, which was a 2-pass heater, to a 3-pass heater. And by doing that at a very minimal cost, I think maybe 1/5, 20% cost of the conventional modification, we were able to accomplish that objective. So we have been providing unique value-added solutions to our client. We don't believe in selling new burners, new fire heaters, and our focus is work as a part of your team and come up with the fixes, do a root cause analysis, and provide you the correct solution. Our motto is do it once, do it right. And we are very fortunate that we have been able to work round the clock, practically round the clock, because of the time difference in two offices of US and India. And we have been able to execute projects very, very fast and at a very, very low cost. The reason being we are a very lean and mean organization. We don't have a sales manager. We don't have a business development manager. I am the one who is doing most of the sales myself, and we have a project manager who also functions as engineering manager, So we are different hats at different times, and we have been able to execute projects at a very, very tight schedule, In 2 months, 3 months, 6 months, we have been able to supply fire heaters. So that has been our mode of working, And what we request all our clients, we request all the attendees is, give us your worst heater. Give us the heater which has been causing you sleepless nights. Just give us the heater and we will guarantee that we will make that heater from the worst to the best, And we have done that. I mean, the proof lies in the pudding. I mean, we can give you several references where we have been able to take heaters, understand the problem, and fix it. Let me tell you a story where we worked with our major customer, and we have been working with them for almost 20 years now, non-stop, maybe more than 20 years now. So this company, this refinery had a cat feed hydrotreater heater, and they had been having two failures in the convection section for past 5 years, and they were tired actually. So they came out with an inquiry for a study and to come out with the recommendations for that heater, And there were 3 competitors. I was just a very small company, but there were 2 very big established names. And I went for the sales meeting with the client. And what I did was I took my solution along with me and I presented to them in the sales meeting. I did not even have the order. I told them this is how I will fix your heater. And the client gave us the order. We implemented it. The problem was solved. There was no more tube leakages. And that company became our permanent client for the last 22 years now. We have been working in that refinery for almost non-stop for 25 years. So that's the type of relationship we build with our customers, Most of the business we get is repeat business. And we have been working on all types of heaters, reformer, crude, hydrotreaters, vacuum heaters, CO boilers, waste heat boilers, SCR units for NOx reduction, ultra low NOx burners. I mean, we have even started working on steam methane reformers. So you name it and we work on it, and we will be very upfront. If we cannot handle a task, we will be very upfront and tell you we cannot do it. This is a list of our customers, and the top 4 clients. We have been working with these clients for almost 15 to 20 years non-stop. Actually, it's not that just those. We have worked with other clients also. Most of the business is repeat business what we do. So these are our engineering capabilities. We have all the capabilities of process design, CFD modeling, and we undertake turnkey projects. We want to demonstrate that whatever we are preaching or whatever we are recommending, we will be more than happy to implement it, and then also to guarantee you with our performance guarantee. It may be somebody's XYZ heater, but we are so confident that once we revamp it, we can guarantee the performance of that heater. That's how confident we have been. And these are, as I said, these are our 3 patented technologies which we have been using to help our clients. And most of these technologies have been able to reduce the cost of projects substantially and improve their return on investment several times. So we'll be talking about 2 technologies today. And heaters, as you know, are a complicated piece of equipment. They are major energy consumers, and refiners are always trying to recover more and more products. They want to be profitable. Refinery is a mature business. In fact, there has been not a new refinery in United States for the last 50 years. 1974 was the time when the last refinery was built in US. After that, there has been not a new single refinery. So what refiners have to do is to keep on overfiring, keep on revamping their their fire heaters. And when they do that, they experience short run lengths. So we help them improve their run lengths. They are, as I said, they are also a major source of greenhouse gas emissions, NOx emissions, sulfur dioxide emissions if you are in an oil firing. So all these things that makes fire heaters a very important piece of equipment. So what are we going to talk in the next 45 minutes is basically talk about fire heaters, talk about the basic combustion process, why there are problems in fire heaters, how our inclined firing technology can help you, talk about stack design and damper design, and how smart dampers can improve the performance and reliability of your fire heaters. So those are the 2 technologies we will cover. So I'm presuming most of you are familiar with fire heaters. I'm hoping you are all from operating companies and you have fire heaters in your business, in your installations. Most of the fire heaters have 3 major sections: radiant section, convection section, and stack. And we burn fuel gas with combustion air to generate heat, and that heat is transferred to the fluids which are flowing in pipes in radiant and convection section. And the flue gases after the heat recovery are vented to the atmosphere. I'm mentioning fuel gas here, but there are still a few refineries which are burning fuel oil. And burning fuel oil is almost, and burning fuel oil and fuel gas is almost like day and night difference. Fuel oil combustion is very, very challenging. And thankfully, because of the pollution concerns, very few refineries are burning fuel oil now. So safety, I mean, combustion is basically a very dangerous business. Actually, combustion is nothing but controlled explosion, So any upset can cause unsafe conditions and high pressure at arch. Efficiency is again an issue which needs to be at the forefront, especially for cost reduction and for greenhouse gas emissions. Reliability again is a very, very important. I mean, we have seen several heaters, refineries, which have short run length issues and it costs them millions of dollars. And the reason we are talking about these issues is that there are two components which the operators are operating or adjusting, and one is a stack damper and other is a burner. And both are very inexpensive components as compared to the total heat cost, but they are very important. And somehow, I'm very sad to say that both are neglected and need a lot of improvement, So, and the improvement is possible. So combustion is nothing but an oxidation reaction. We are combining carbon, hydrogen with oxygen and generating heat. And when we generate heat, we have flame produced, and it is this flame which can cause havoc. Flame temperatures can go as high as 3300 degree F or even higher. So we need to control the flames, we need to control the combustion. And fuel costs, especially in India, Southeast Asia, the fuel cost is very high. So you want to be at the maximum efficiency. In fact, most of the inquiries we receive from India, especially refineries, have been focusing on efficiency improvement. I think somehow Modi ji has said, hey, we need to have the maximum efficiency. So every refinery, Indian Oil, HPCL, we have been seeing their inquiries, and their single focus is how to improve the efficiency of their fired heaters. So it's still a very important issue. It's not important in US, but definitely in the rest of the world. So the challenge we have is how do we get efficient combustion, And we have got two things to work on. One is the fuel gas supply. The fuel gas supply is the easy part because we have a control valve which controls the supply of fuel gas, consumption of fuel gas. It is driven by the outlet temperature of the product. So fuel gas control has been very, very standardized way of controlling fuel gas. But it is the air control which causes challenges. What we have found is by experience that you get the maximum combustion efficiency when you keep about 3% oxygen in the flue gas, about 15% excess air. So the challenge is how do we control the combustion air? And especially if you're talking of natural draft heaters, there are two things we have, two areas where we can control. We can control the burner registers, and it is a challenge here because despite all the advances, the burner registers are mostly manual. Now imagine if you have a furnace with 20 burners, you change the load. Now you want to ask the operator to go and adjust the registers, almost impossible. If you have a ethylene cracker, or if you have a steam reformer with 200 burners, then it's almost impossible. The second driving force, or the second parameter which we need to control, is the draft at the burner. So draft is basically the driving force, the differential pressure between the outside and the inside, and high draft will mean more air, more combustion air, and low draft will mean insufficient air. So draft is a very, very important parameter along with the burner registers. And these two things together are controlling the excess O2 or the combustion air supply. And that's what we want to focus today about when we talk of dampers. And the second thing we have been talking about is the flame impingement, high tube metal temperatures, coking, run length issues. These are the issues faced by a number of refineries, our operating clients. I forgot to thank my team in Delhi office who has put together this excellent presentation for you. So my team has worked very, very hard for the past 4 weeks to put this presentation together, and they have done an excellent job. I'm just delivering the message. So flames are very important to control and keep them away from the tubes. And the challenge has become very high because the combustion process has been changing in fired heaters for the last at least 50, 60 years now. When the fired heater industry, the refining industry started, we used to have premix burners. Premix burners are the burners like your home burners, what you have in your gas stove, the kitchen gas stoves. And those flames, when you see those flames, are really nice, beautiful, short flames, So that's how the flames used to be in the fired heaters, very nice, short flames, actually. But the times changed. Initially, the fuel gas composition used to be very stable, so we were able to use premix burners. But as the refinery started expanding, becoming more complex, we changed these burners from premix to nozzle mix. And when we did that, we got a lot of flexibility now in the fuel gas composition, but the flame length doubled. From the premix to the nozzle mix, the flame length doubled. And then in 1970s, we realized good combustion produces a lot of NOx. So we need to start limit, and that NOx impacts the human health. The smog, what it produces and other issues is not good for us. So we have to limit the NOx production. And so the burner vendors started working on limiting the NOx production, and they found out that if they stage the combustion, if they elongate the combustion, if they delay the combustion, the NOx goes down. But there was another side effect which they never told us, was that the flame becomes longer. The flames, instead of being 1 foot per million BTU, became 2.5 feet per million BTU. So the fired heaters have not changed. The fired heater radiant sections have not changed, but the flames have now become extremely long. And when the flames become extremely long, they lead to flame impingement. So that is a new challenge which the industry has been facing since last 20, 30 years. And finally, API recognized it, actually. API is a body of all American petroleum refiners. And they finally recognized it, that it is a big problem for them, So our solution is very relevant for avoiding flame impingement. A high tube metal temperature is very, very common. Anytime you have flame impingement, you will lead to coke buildup, and if you have even 1/8 of inch of coke, it will add to 100 degrees of your tube metal temperature. So this is a slide. It tells you what happens when you coke up. So nothing good happens, I can only tell you that. It also gives you the thermal conductivity of coke as compared to the metal thermal conductivity. So what is inclined firing technology? Inclined firing technology is very, very simple. All we are doing is inclining the burners towards the center of the heater. We are inclining the burners to direct the flame away from the tubes. That's all what we are doing. Historically, conventionally, the burners used to be straight up at 90 degrees, and we realized that that was causing a lot of flame impingement. And if we incline these burners by 3, 4, 5, 7 degrees, there is a big change in the flue gas patterns. The flames are away, and the tube metal temperature goes down by almost 100 to 200 degrees F. That's how much reduction we have seen in fired heaters. And some of these fired heaters have been working now for almost 10 years now without any issue. So very simple concept. All we are doing is moving the flames away from the tubes. And you have to remember that the flame tip is the hottest component, is the hottest portion of the flame. And if you keep that flame away, which is typically could be at 3000 degrees F, no metal can withstand flames, So if you keep that away, you are in good company. You bring the flames closer to the tubes, they will have nothing but issues, problems. So the basic principle underlying our inclined firing technology is move the flames away from the tubes. We cannot increase the size of the furnace now, which will be very, very expensive. So we said, okay, let's come do the inclination, and by doing that, we are able to get spectacular results, So that's what we want to tell you, that if you are having high tube metal temperature issues, contact us and we will be able to help you improve the performance of your fired heaters by putting our inclined firing technology. We can use your existing burners. We don't need new burners. We can use your existing burners and put them at an angle just by modifying the floor. And we will show you the results by doing CFD. CFD is a very important tool for us to demonstrate how your flames are looking now and how your flames will be looking after we fix it. So we will do extensive CFD to prove that the technology is going to be working. So these are some of the benefits of CFD or inclined firing. Basically, we have seen it gives improved flame patterns, better flue gas recirculation around tubes, uniform tube metal temperatures, and uniform heat flux. We have seen time and time again. Elimination of hot spots, increased heater run length, longer tube life, reduced coking rate. So everything is better. Everything is positive. I want to tell you something. We are working with a client in US, and that client has been experiencing tube guide failures. It's a bottom supported heater, and the intermediate guides and top guides have been failing. And this problem the client has been experiencing from day one. These heaters were built in 1980s, and from 1980s to today, the client has been having failures. They came to us, we looked at it, and it turned out that the burner flames are so big. Existing burners are so large flames, has large hollow flames, that it causes tube bowing, and once it causes tube bowing, the guides fail. So we are recommending, we are recommending to put, instead of one burner, put 4 burners at an angle, just like what you have seen over here, and solve their problem. So I think it's a very effective solution, very simple solution for high tube metal temperature problems. This is a same thing, as you see, as the elevation goes up, we keep on increasing the distance between the burner and the tube. This is from a job we did for a Valero refinery, a crude heater, and they had tube bowing issues and high tube metal temperature issues, and we put new burners. And this heater was designed so tight that even API 560 minimum clearances were not there actually. So by putting inclined burners, we were able to solve the problem. The heater has been running fantastically for last 6-7 years without any shutdown. So that is the benefit of inclined firing. This is again another thing. You can see in the vertical firing, you can see hot flue gases touching the tubes and causing hot spots, tube metal temperatures, flame impingement. And when we do inclined firing, you can see it's a cold flue gas surrounding the tubes. That's how these things work out. So we have been able to demonstrate tube metal temperatures lower by 100 to 200 degrees in most of the heaters. In fact, we are so confident of our inclined firing technology that we provide it in almost all the fired heaters that we supply. All the vertical cylindrical fired heaters that we supply, we provide it as a standard feature at no cost, because we feel it will improve the performance of your fired heater spectacularly. This concept can be used in double fired coker heaters. It's not that you need it in VC heaters. It can be used in coker heaters. It can also be used in reformers or platformer heaters, UOP platformer heaters. You can have the inclined firing if you are having high tube metal temperatures. We can help you lower the tube metal temperatures by, again, inclining the burners. We can use your existing burners, incline them, and get you better performance. So that's what I wanted to present about our inclined firing technology, especially because we feel if you want longer run lengths, it's a very inexpensive solution. It's a very inexpensive root cause analysis solution, established solution you can use in your fired heaters for lowering tube metal temperatures. So let's move away from inclined firing technology and talk about dampers. Dampers is also a very important component, especially for natural draft heaters. And I feel that there is so much scope of improvement in dampers that just by modifying or improving the reliability of your damper will go a big way. This is a picture of a heater where you can see the damper is being controlled by manual cable and winch. And sometimes I get surprised or shocked that the refiners are installing TDLS, oxygen analyzers, CO analyzers, and yet depending on a manual cable and winch for controlling. So how can you get precise control of combustion air by using cable and winch? It's almost impossible. And also, refiners are trying to minimize the cost, so they keep on minimizing the number of operators, so the task becomes even more difficult actually. So what we find is there is some sort of a disconnect, that people have not understood the function of a damper. And I think it's the heater vendors to be blamed actually. They have not communicated the importance of damper to the end users. The vendors see, the suppliers see the damper just as a plate on a shaft, on a tube, plate on a pipe. So, which is not correct. That could be the case 80 years ago or 100 years ago when we started the industry. I want to tell you, when we had premix burners, you don't even need a damper actually. So those heaters where we had premix burners did not require any draft control, because it was the fuel gas pressure which was inspirating air. So it was not required. But ever since we went away from that, the burners changed, the type of burners changed, the dampers became important. Actually, dampers became like a final control element. Think of damper as a upstream pressure controller. Think of damper as a butterfly control valve, and then you will realize the importance of the damper. And even though the industry has focused on oxygen analyzers and there is an excessive focus on efficient combustion, but there are two things which we need to talk about. We need to talk about oxygen and draft. Draft is equally important, because high draft will have a lot of tramp air. You will have air leaking from peep doors, air entries, header boxes, everywhere. Fire heater is not a pressure tight structure, it's not a pressure tight structure. So we can have air leaking from anywhere and everywhere. So what we need is, we need a reliable stack damper. We need a reliable draft control damper. And my observation in the last 30 years, ever since I started focusing on dampers, is that we blame the operators. We blame the operators that, hey, they cannot control the draft. They don't adjust the excess air. But my study says that it is the design deficiency of the dampers, and which basically makes them inoperable. The dampers are so much oversized that getting a precise control of draft is almost impossible. And that is one reason why we came up with smart stack dampers, because they are operator friendly. We are able to customize each damper to that furnace by checking the draft profile and customizing it. So what happens is, you first have to understand the fire heater, the draft. The draft varies with ambient temperatures, and it is an established fact, no matter where you are, whether you are in US or India, nights are always cooler. By 10 to 15 degrees F, nights are cooler. Maybe in Middle East, it's even, the temperature difference is even more pronounced. But when the nights are cooler, you will get more draft, higher draft. So if you have stack damper at the same position, what will happen? You will have more combustion air going through the furnace. So you will have inefficient operation in the night. So stack dampers needs to be adjusted at least twice a day, and anytime you change the load on the heater. So it is almost like it's a control valve. It needs a very reliable operating mechanism. It should be correctly sized. All control valves are customized. We calculate the CV and we specify the CV, and the valve manufacturer ensures that they are customizing the control valve. But not in the case of fired heaters. We don't do any calculations. Whatever stack diameter is, we provide a full size butterfly control valve or a damper. That's what we do. So what happens is, instead of providing a 3-foot damper, dia damper, we end up providing a 6-foot dia damper 4 times. So when you have a 4 times area available, what the control becomes almost impossible. It's almost like the controlling will be almost in the last 5% of that range. This, what you want is, you want to have a linear control, equal percentage control valve. All of you would have heard equal percentage control valve, and that's what you want to have. But with oversized dampers, it's almost impossible. So we are not able to control draft, and as a result, I think 9 times out of 10, the stack dampers are left fully open. The operators give up and they just leave the stack damper fully open, and no draft control is achieved. And that's not because of operators, that's because of the inherent design defect in the stack dampers. And we are to be blamed. The designers are to be blamed, because the process designer specifies 10 to 20% margin in the duty. Then API 560 specifies 120% margin on the stack. And stacks are sized for the worst or the highest ambient temperatures. And then the process engineer comes out and gives the stack dimensions. And then the structural engineer looks at the stack and he says, I cannot make a 100-foot tall stack with a 3-foot diameter. So he increases the stack diameter from 3 feet to 7 feet to have a good L by D self-supporting. And they never go back to the process designer that I have provided a 7-foot diameter stack. And that's the end of the story. We end up having a 4 times, 5 times bigger damper. Oversizing is good, but you don't need to oversize the damper. If you oversize the damper, stack damper, you will have nothing but problems. So since we use self-supporting stacks, L by D ratio is very important, and I'm just giving you some typical thumb rules that if you have a 100-foot tall stack, the minimum stack diameter is about 7 feet, and if you have a 150-foot tall stack, you will need about 10 feet for the 150. So L by D of 15 is generally considered a standard in structural engineers. So with that, you can either make a straight stack or conical stack or a telescopic stack, whatever you do. You end up oversizing the damper. Because even for the telescopic stack, most of the time we end up providing the damper in the base. You want to control it and also access it. So if you provide it over here, it will be the best, but we end up providing over here, and that's where the problem starts. So finally, API, if you know American Petroleum Institute, I in fact also a member of that, realize the problem. Realize the problem of oversizing of stack dampers and have now put these three conditions in the API 560, which is a Bible for fired heaters. They talk about damper position no less than 20% open at minimum heat release, no more than 70% open at design heat release, and damper travels at least 30% from minimum to design heat release. These things have been put, but not a single stack dampers meet these conditions. Not a single stack damper in the current scenario meets these conditions. So what it means, every damper needs to be modified. I don't know, there are at least 10,000 heaters in US and maybe 50,000 heaters worldwide, if not more. And all of them have stack dampers which are oversized, which needs to be fixed. API is a very good document and it does talk about number of things, but unfortunately it only talks about the mechanical portions. It does not talk about the process. And this new requirement which they have put, we will see how the fire heater designers react to that and how they will be able to satisfy these conditions. But the problem is that the issue is we have a real problem with the stack dampers. So this is showing you the draft availability, and when you start reducing the load, the draft remains the same, but the load goes down. You can see the bottom curve over here, So over here, that becomes the differential becomes a lot higher. So that's the problem with the stack damper, that draft, they have to kill so much draft, excessive draft. And if they don't kill it, it will lead to, the draft will go down to the burners and they will be operating under very high draft and inspirating a lot more combustion air. So all we are doing is customizing your stack damper. That's what we are doing. The smart stack damper is nothing but a customized stack damper which matches with your operating conditions, which matches with your design conditions. We simulate the heater, check the draft profile and see how much pressure drop do we need across this stack damper. And then we change the damper blades and operating characteristic. That's what we are doing. We are resizing the damper and matching it with your heater. So this is what you want to have. Ideally, you want to have an equal percentage. When you open 20%, the flow should be 20%. When you open 60%, the flow should be 60%. Even that's what you are kind of looking for. But that doesn't happen. So that's where, whether it's a parallel blade damper or whether it's an opposed blade damper, both of them don't work. And the reason is oversizing. I used to think opposed blade is better. It is better, but if it is oversized, it still doesn't work. So what you need is a correctly sized damper. And that's what we are doing. Basically, we are customizing it, and we have two sets of operators. One is for major control, another is for finer control. So one is for your everyday control, and the second one is for not every day, but maybe every month or every week, depending on how your loads are changing. And we have kind of gotten away from cable and winch and put pneumatic actuators, which have much better controlling characteristics. We can do it from your control room. You can do it from grade. You don't need to go up. You know exact openings of the stack dampers. So it's a much more operator friendly customized damper. So this is a parallel blade damper. This is an opposed blade damper. But what we are doing is we are providing and changing the control characteristics CV of the damper, by putting two controls. So why do we put two controls? Because it gives you a flexibility that at any event, suppose you want to go back and increase the capacity of your heater, then you say, okay, I want to, or at any unforeseen conditions you want to open the stack damper completely, you still have that flexibility. That's the reason we are giving two actuators, so that you don't lose your flexibility of operating with full stack damper at any time of emergency or anything. So if you want a customized stack damper, if you want efficient control of your fire heaters, send us your inquiry for your heater and we will be able to quote to you. We can take your existing stack damper and make it a smart stack damper. We can reuse half the components, So that will lower the cost, but it will become a lot more efficient, So this is a heater we are replacing in one of the refineries, and we are implementing both our technologies. We are implementing inclined firing as well as our smart stack damper. This heater is about 90 million BTUs. The challenge the client gave us was that the new heater should be able to fit on the existing foundations. So when we looked at it, the heater design was very, very tight. We could not increase the diameter of the radiant section because of the foundation limitations, because of the space limitation. So we said, what is the best thing we can do? We can go for inclined firing. And I've already told you enough about inclined firing. So that's what we are doing in this heater. We are putting 8 burners at a 5-degree angle. And the other thing which we are doing is putting stack with dual actuators, Not required by the client, but we ended up doing this thing for them. So that's all I have. I can keep on going, but this is basically what we want to talk about today, that by using inclined firing technology for the burners and smart stack dampers for your dampers, you can improve the safety, efficiency, and reliability of your fire heaters. Want to thank all of you for giving us a patient listening. We had more than 100 people registered for our webinar. We will make this webinar available on YouTube very shortly. In case you missed it, you will be able to you will be able to watch this on YouTube. And if you have any questions, send it to us and we'll be more than happy to get questions from you, So again, thank you all for very much for giving us an opportunity to present our technologies, and bye.